Hi, everyone. I'm James. This is Jose. We're software engineers at Discovery. Very excited to be here to show you or share with you some of the cool stuff we're doing at Discovery. Give Jose a second to connect the screen. We have an interesting problem at Discovery that we're trying to solve. And that problem is we have multiple networks. Some of you may not realize, but Discovery also has many channels: TLC, Animal Planet, Food Network, HGTV, etc. We have 18 different channels. Might as well go on to the problem statement. So we have 18 different channels that we're building applications for. We're building apps on mobile devices, connected TVs, web. And the obvious problem is you don't want to build 18 apps for, one for each of these brands and then maintain them. So our first approach was we built a very obvious solution, which is single application. You can change the logo, you can change the color palette, and you have an app for a different platform. And that worked well for us for our first version. But you quickly realize that the audience for one network, Animal Planet, is not the same audience for another network, TLC. And we're not really doing right by the customer in this fashion. We're doing right by the business because we're being extremely efficient, cost-effective way of developing applications. But Discovery is a very consumer-focused company, and we want to do better. So we thought about a solution in which we can provide custom experiences that are targeted specifically for an audience for one of our products. At the same time, we are going through a bit of a transformation at Discovery where we are beginning to operate more as a global company, where we traditionally had a US group and European group. We're now coming together and we're looking for efficiencies across the globe. So the solution we have that we had started with this is actually lending itself very well to that. And that's what we want to dive in with you today.
Yeah, so I think as James covered, we've got a number of challenges. Fractured delivery platforms, I think, is one of the biggest ones. And really this slide is just an opportunity to share this image with you. If you haven't seen it, I don't know, I've seen it a couple times. I had to add it to my deck. It really kind of tells the story of what front-end developers are working with as far as platforms that we're delivering to. And this doesn't even include connected TVs, smart TVs, and other smart devices. The second aspect that James mentioned is the breadth of our product offerings at Discovery. So if you think about the number of devices, the number of products, all of a sudden you're talking about a really like a almost unsurmountable challenge to first build these things, but then support them and then allow them to mold to the customer experience and to the feedback that we're getting from our users.
And our first approach to this was we had, like I mentioned earlier, we had a very templated system. Change the logo, change the colors, and you have a new product. But that only worked in one vertical, right? So that was the website could do that, and then our iOS app could do that, and our Android app can do that. And we still had this problem where we had multiple code bases to support, yet we were continuing to add on more devices, which only compounded our problem. We added on Xbox, we added on Samsung Smart TV. We're looking at other gaming consoles and TVs in our roadmap. And we wanted to see how can we maybe solve our problem similar to what we did the first round for the one platform, but how can we reduce our code bases from 9 and growing to the fewest? And that's how we came upon React Native. React Native was something we didn't go into lightly. It's something that we proceeded with caution. The original idea of going with React Native sounded too good to be true to us. So naturally, all of the developers on the team were very skeptical about moving forward. So we started off creating a very simple POC just to see, can we actually build something that went on mobile devices, but also went on Fire TV and tvOS. That worked really well. It was a very, very quick and dirty POC. But then the engineers had some really good questions. What is the code base going to look like when we try to take all of these different applications and all of these different platforms? It's going to be a nightmare of if statements and switch statements and all this logic to kind of segment it so we can target specific platforms, but yet still have it all in one code base. We're just going to pull our hair out and wish we just had separate code bases. We also had performance questions, support questions, device hardware questions. So we set out to do a second POC. And that second POC, we wrote down all of the another big problem with the engineer, not problem, but concern with the engineers was the development ecosystem. Everybody was familiar with Xcode. Everybody was familiar with Android Studio. And they were concerned what the new development ecosystem was going to be like. So we identified all the issues that the engineers raised. We set out to do a second POC. We answered specifically those questions. And when we were pleasantly surprised with the outcome, we set off on a mission. And that mission was to develop this platform, which we're going to dive in today.
Yeah, and I think James mentioned our team of engineers. I definitely want to make sure you understand that the work that we're showing and the success that we're sort of reaching, it's not just James and I working on this thing. There's a crew of people. A handful of them are here. So later on, if you have any questions about what we're talking about, just look for somebody in one of these snazzy blue shirts and you hit them up with whatever you have as far as technical and even cultural questions for discovery. So talking about our approach, we sort of boiled it down for this presentation into a set of three main pillars, those being atomic design, the idea of a component library, and flexible theming. Again, maybe none of this is super new, but I think the approach and how we're implementing it is fairly unique. So by a show of hands, how many people are familiar with atomic design or the philosophy around it? Okay, so some, but not a whole lot. So I'll spend a minute on this. This is sort of like a philosophical approach to breaking down user interfaces that works with the sort of scientific system of a smaller element is used to create larger elements. So, and then from those larger elements, you create, objects, or in our case, organisms. And this was developed by a guy named Brad Frost. If you're curious about this, that URL is his website. He's got the whole book there is available as a PDF. You can also purchase the paper version if you're into paper. I like paper. Yeah. So again, it's something fairly commonplace. It makes a lot of sense. Small things make bigger things make more complex things. Simplicity begetting complexity.
Something I just wanted to throw in there was atomic design worked out really well for us with building a useful dialogue between the engineering team and the design team. So the design team is very much on board with the atomic design approach because it adds consistency to their design. I can imagine how many people here have worked on comps that they've gotten from design, and headings are implemented 17 different ways, right? Or buttons are implemented 15 different ways. They go into Photoshop, they scale something because it didn't fit, and then all of a sudden you end up with a font size that's just slightly different than everything else. Atomic Design kind of solves that problem because the design team has a language and we have a language that is exactly the same. They're building reusable components as small as possible, an image, a button, and then composing those elements to make even richer elements like molecules and then eventually organisms. And they're using Sketch in a very cool way in that they're leveraging the symbol system to organize the atomic design as atoms, molecules, and organisms for us so that when we're taking those compositions, we're easily translating them into code.
Yeah, that's right. And you know, this idea of atomic design, again, we're using that name. Like James said, it's easier to understand. It's a nice cognitive framework for relating this concept across everybody. I mean, designers, product people, developers. It took a minute to kind of like align, but once it clicked, everybody kind of like started seeing it and implementing it.
And the design team has been excellent partners with us on this.
Yeah, and we got a bunch of slides on that. So one thing I have in bold so that I didn't forget to mention it is, atomic design it's a framework, it's a philosophy. You can go like follow the rules very strictly and try to make it work, but sometimes it feels like you're sort of shoehorning your needs into a specific sort of ideology. You don't have to do that. We didn't do that. We used what we felt made sense. We tweaked a little bit. So make it your own if you go and dive into atomic design. I think a lot of this we already talked about, and what everybody loves is faster time to market. Everybody has their own reasons for that, but yeah, another bold one. So as James was saying, our designers are doing similar work, and the design apps right now support this. They're built with this. The idea of symbols and design patterns are already sort of existing in there. So yeah, I just have a couple of slides here breaking down how we approached atoms, molecules, organisms, and ultimately environments. And this is where you see like we're breaking some of the rules. Like if you think of an atom, you might think it's just a type of text or just a single icon. But we have a sort of spectrum of atoms from simple, very basic atoms over to something a little more complex. Like we consider a button an atom, even though a button is a shape and an icon and a text atom put together. Some people might, if you're a purist, you'll go like, oh, dude, that's a molecule. But like whatever, it's a button, it's pretty tiny, and it has to really do with reuse. So the size of it isn't so much as important as how many places you're going to find a same or similar element.
That's right.
So moving up the scale, and I was pretty careful to make sure to include the same things so we can go back and forth. You can see these same atoms starting to coalesce into molecules. So these are some show tiles, some video player elements, and you can see, here's a set of atoms. We put them together in a few different ways, a variety of ways, but it's the same one. It's the same React component, right? Each atom is actually maps to a React component with varying props that make them unique per their use. So just keep going. Yeah. So taking it a step further, we've got organisms. So again, you see some of the atoms, some of the molecules, again coalescing into organisms. So that header block, it's got a button, it's got text, it's got icons. This sort of, think of this as a sliding carousel of show tiles. The sliding carousel itself is the organism because it consumes molecules. And again, similar with this sort of live badge there, you've got an image, you've got icons. And again, these are then in turn reused in a number of places. They get sent props to tweak their particulars. And then finally, an environment. This is where all of these things live. And
it's just important to note here that so far with this approach we did already do in our first version that I was talking about earlier, where it was very templated and colors and logo. The part where we really start to break from is the next part we're going to talk about, and that really enabled us to go custom UX per product while still having a single code base.
Yes. So the obligatory Rick. I love all of the first presentations are awesome. I was looking for more Rick and Morty in the slides. I think this probably accounts. You guys are safe. There's enough Rick and Morty there for everyone. So right, you came here for some secret sauce. You come to these conferences and you're like, man, I really want to see all these heavy hitters are sharing their secret ingredients, and I've got Joe staring at me right now going what are you going to show? Don't do it. Well, I'll ask for forgiveness later. So this is a diagram basically showing a little bit of how we put all of these elements together. And what I'm going to do is, I started with the imagery. We're looking now at something a little more diagrammatic, and then we'll sort of go into a little bit of code. All screenshots, no live coding for me today. It is too stressful. So again, you've got atoms on the left, molecules, organisms, and environments. And what you'll note here as you start to look at our directory structure is that the directory structure also follows this nomenclature. It follows this breakdown. So again, just this idea of reducing cognitive friction with the language and the sort of the verbal framework that we're using when we're discussing these things. So there's an atoms folder, there's a molecules folder, there's an organisms folder.
Yeah, and the importance of keeping these completely separated in code becomes obvious as we start to continue this talk. The atoms that you see here, molecules and organisms, these are built as React components, right? As you would build a normal React component today. And they exist in our binary that is shipped to the user. So one of the things that we're going to start to dive into is the notion that our applications that we send to the store know nothing of the user experience that the application is going to provide. So when we build an application that includes all of the basic foundation features, things like a video player, analytics, deep linking, single sign-on authentication. That's in the core, that's in the framework. On top of that, we have a core UI library, which this is the beginnings of that core UI library, the part in the light blue. That's why it's extremely important that we follow this atomic design, and it'll become more obvious. The atoms that we have on the left make up everything, right? Never trust an atom, it makes up everything. Atoms are on the left, molecules, organisms. We chose to make some of the more complicated or unique molecules and organisms and put them right into the library and bake them into the binary. We have a way to do this outside of the binary as well, which we're going to dive into. The application that we build goes to the store, the user downloads the app, but the app makes a call to a service to get a configuration. That configuration tells the application everything it needs to know about how the app should perform from that moment forward. The next call it makes is a call to the layouts API. And what we have here on the right-hand side is an example of a response from a layout. A layout is going to tell the application which components to display on the screen and which data to populate those components with. So we have now gone from having a single application where it's very template driven and changing the logos and colors, but every product gets the same thing, to a way that we can customize the experience, not only the home screen or a show screen or a video screen, but the screen itself. So each of the routes that the application understands is fed to it, and it doesn't have to have a show screen if that product doesn't need one. It can have a setting screen or whatever other screen that's relevant to that product. And by having the core library be as simple as possible, we can then make up anything we need through layouts, including complicated molecules and organisms, which we'll start to talk about.
Yeah, and like James said, what you're seeing here is the difference between what's in the component library, it ships with the app, and what's coming through these layout requests. And you can sort of, I don't know how well you can see it here, but you can start to see, where we're consuming a text atom here. There's a display note here. There's another text atom here. So it's sort of combining these pre-built components that are in a library with this expressive template language that's actually coming to the app over the air.
So what Jose was referencing was each element that is going to be rendered by the application, we're referencing either an atom, a molecule, organism by name, by ID, and we're feeding that component metadata about where to display and how to display, sizing, positioning, but we're also feeding it the data that it's going to populate itself with, including other things like pagination information, refresh up information. Maybe it's a component on the screen that changes over time. It's included with information on how to make and how frequent to make those requests.
And this is really what leads to the flexibility that James was alluding to earlier in the talk, the ability to A/B test on the fly, the ability to sort of eventually micro-target individual sort of consumer sets, or all the way down to probably individual consumers, and serve them a unique experience within the same application without having to ship another app.
So the response is influenced by a number of things. It's influenced by a content creator who can go into the CMS and make conscious decisions on the layout response. It's influenced by artificial intelligence to automatically make recommendations based on user behavior. It's influenced by A/B tests. If we want to run something, a control, and then multiple variants. And these factors influence how the response is eventually given to a particular user, including the product itself. So whether it's HDTV or TLC can also be an influencing factor on the response.
Super cool stuff.
We're going to start to move faster because
we're gonna
running out of time.
We're gonna speed run. The next pillar, I think, is this idea of a component library. And how many folks in the audience are familiar with Storybook? Okay, a lot,
awesome.
a lot more. Good. So then I can totally speed run. So just to, I don't know. I love this quote. It may take a second to sink in. But this whole idea of pattern libraries, defining patterns, seeing the commonalities, and building from that. So the Storybook, as you know, it's one of our favorite things. It's open source. It's extensible. You can use it as it ships. You can add to it, and it gives you this sort of workbench. I personally, I'm fairly new to the stack, and I couldn't imagine working in React without something like Storybook to preview these things as I'm working.
Yeah, and because so many hands went up, I don't know that we have to spend much time on it, but other than to just show, if you look on the left, you'll see we're still following that atomic design organization in the left. I mean, that's really a critical part to our success.
That's right. And we'll probably go quickly through this, but it's not bolded, but it has a little emoji next to it. So knobs are probably like my favorite thing about Storybook, the ability to sort of tweak values and prop values and test them right in there live.
Yeah, and just to touch on that 30 more seconds is, what's really useful about those knobs is it gives the designers an opportunity to test the components before the components make it into the application. So they can begin to really stress test, what does 2 lines of text look like? 3 lines, do we correctly put in the ellipsis? Do we truncate it? Do we do all of those things that maybe they haven't thought of, but now they're going to see when they start playing with that component? And it's great because you can put each one of those components in various states, which are very difficult to put your application into those states just by running the application. Maybe you have some edge cases and you end up hard coding some values in your application to force it into a specific state just to test the component. Totally don't have to do that. Can do it all through Storybook, which has been a great time saver for us.
Yeah, and I think if there was one drawback to knobs and stories in general is that, if you're writing a ton of components, there's a lot of kind of boilerplate that you have to throw in there. So one of our devs, Sarah Heacock, who worked with me on making this dynamic knob generation system. So, I mean, it's too much to dive into right now, but it's a good idea. Like if you see something that's taking up a lot of time, think about ways of automating this. Now, for us, we can throw a component in there and it will automatically generate all of the knobs, add the default props, add in dynamic props from the theming layer, and pre-populate all of the drop-downs and sliders with what should be there. So our boilerplate within a story shrinks by a huge chunk. And that's one thing we're trying to figure out if we can offer that as an open source add-on. We're in conversations on how we can do that. So the third pillar is this idea of flexible theming. Again, nothing super new. There's lots of existing libraries and frameworks. Somebody mentioned solid components earlier. But we opted for rolling our own and doing something sort of fairly simple, but that works with the level of flexibility that we need and the base system that we're working with. So we have this idea of global theme variables, a set of brand colors, a lot of descriptors on the typography. Those were really sort of where we saw a lot of change in the designs, like James mentioned. Originally there were like 32 type treatments. We were able to narrow it down to three text components, each with some variability.
And while this slide is up, one of the interesting parts here in our journey in doing theming was we ran into an obstacle with the 18 different brands that we had. We went in with the naive idea that all we had to do is have a color one, and then the text is color one, the headline is color one, and then TLC is going to make it red, and another brand is going to make it blue. And we ran into problems as the designers started to stress that. And the problems we had is what's a primary color for TLC is not necessarily the right primary color for another brand. And we ended up with weird scenarios where color one was the headline for all but 3 brands, but they really wanted color 2 for the brand. Mm-hmm. So the way we solved that is by having 2 layers of abstraction for theming. One was to set up all of those brand colors, but the second is at the component level. So the component defines everything that needs to be styled, and then you can map that back to the original set, which is for this component, for this product, because it's at a product level, this product, we want color 1 for the headline, we want color 2 for the background, and we were able to separate it out per product very easily and keep the files nicely organized so it didn't become difficult to manage.
Yeah, yeah. So again, the global stuff is sort of the abstract definitions, and then we have the semantic definitions of how these abstract things are shown, and you can kind of see that happening there. And the default theme file manages that sort of mapping. So the next level of this is this idea of product overrides. So obviously, investigation discovery isn't going to have the same look and feel as Animal Planet. And for any of our people in the audience, I took some liberties with the Animal Planet design. Don't tell Matt Kruger. That's not really what it's going to look like, but I just wanted to make it look as different as possible. So these are all the same buttons. Default theme is changing, and again, in some cases, those global definitions are changing. And beyond.
So just to touch a bit upon the theming, we have 3 different ways to theme components. So we have the default theme. So when you're building a component, you have to provide it with a default theme. The second is a product theme. So a product theme will go across all of the components within the product. And then the third is through the layout response. At a layout response, because we're doing A/B testing, we have the ability to do overrides. So you may override a component just for a variant to say, people more likely to press an orange button or a green button for sign up. So we have the default theme, you can override it with the product, but then you can override it with the layouts. And the layouts, and I don't know if we really touched upon the layouts part, but the power of the layouts part is you're able to create custom UX experiences by referring to components that are in the library, but also by creating custom components through markup. So our layout renderer inside the application could easily reference any of the baked-in components, or it can understand the markup that we've created for the layout response to create components on the fly. And that has a lot of power for us because we're able to ship UX updates without publishing to the store, right? So when we make a change to the user's experience, we create a new screen, we modify a screen, that doesn't require an App Store update. And for those familiar with the App Store updates, there's a turnaround on that. So
and a process.
And right? A process, yeah.
And some risk. So yeah, product overrides. And yeah, layout-based, the same. And then further beyond products, we're also able to do per platform overrides. So again, we know that a smart TV component is going to have some variance from an Android device component, from a tablet device component. So that is built into the system as well. And I think I actually have one slide again, which I'll probably get in trouble for, but this shows the way that override system works. So at build time, when we build the app, you start with your most common variables. You have your global stuff. You lay over top of that the default theme, and then if there's a product override, you override that default theme with the product specific override. But also, if there's a product-specific override for, say, tvOS, you override those all the way down. So what you end up with in your build is sort of the delta of all of these. And currently we're doing it on a file basis, so it's a file-based override. But we're working on doing something a little better with deep object merges and having to have the deltas within each one of these files. So I love this.
Yeah, and that became really important for us with making distinctions between Apple phones and Android phones with some slight design tweaks.
Yeah. So, that was a bit of a speed run. I apologize, but again, we'll be around for questions. The results slide, you can say a little bit, and then...
Yeah, so, I mean, so far it's been extremely successful for us. We started off with building this for our 11 brands within the US-based discovery. We've acquired Scripps not too long ago, brought on 7 more brands, and the system easily scaled to go from 11 to 18. We are now going next week, actually, Jose and I going next week to Paris to do training on our platform with other discovery business units. So folks from Golf and MotorTrend and Dplay will all be at the workshop, trying to learn EOS and see if it's the right platform for them or not.
I think the cool thing about that is that we didn't sort of sell it to them. They came to us. They heard about it through the organization and said, "Well, that looks like something that we can use. How do we work together?" And the hope being that as more of the organization, if this framework is used globally, not only does it mean that there's less code base and less maintenance, but there's also more contributors to this to make it better and sort of expand further.
Yes, so Discovery has been making a big investment in technology. Traditionally, Discovery is known as a media company, and we have a tremendous amount of content IP. We own all of our content. We are now making a big investment in technology and owning our software IP. And we're developing IP internally, and we're making a big effort in letting others know about the engineering capabilities of Discovery. We've tripled in size since I've been there, which is about 3 years. And we're continuing to grow, so if anybody's interested in the cool stuff we're doing and wants to talk to us afterwards, you can find any of us in these blue shirts. We're happy to talk to you.
Oh, I got one more slide. I apologize in advance. There's a little bit more Rick and Morty. So earlier on in the presentation, there was a slide. We talked about showing you the special sauce. Every slide that had something that we considered special sauce had a Mulan Szechuan sauce packet on it, and I'm wondering who was paying attention at that level.
Anyone?
8?
I heard 8.
Close. Anyone else? 7.
I heard it right here.
7. All right.
7.
Yeah. So come find me later, and I'll take your email address, and we'll see if we can get you some
swag.
Some disco swag. Yeah. Thank you. Thanks for listening. I know that was a lot, but I really appreciate it. Thank you.